Okay, now we will see different page replacement algorithms. There are four types of page replacement algorithms. First in, first out, least recently used, least frequently used, and optimal page replacement. Okay, now we will solve problems for all the four types of algorithms. First, we will see first in, first out, also known as FIFO. In the problem, the reference string is given, okay, and also the size of the main memory is given. So main memory has F1, F2, and F3 three frames. And what is this reference string? Reference string represents the page numbers, okay, this page numbers required by the CPU. So what we have to do is, this is your secondary memory and this is your main memory having three frames F1, F2, F3, and initially main memory is empty, so we have to bring the pages from secondary memory and place it in the main memory. So first page is 7, so we are bringing page number 7 and putting it in the frame number 1. Why? Because initially F1, F2, F3 are empty. So now we'll solve this problem step by step. First page is 7. Okay, initially all the three frames are empty. So we can put this 7 here, frame number 1. Okay, and it's a fault, page fault. Why page fault? Because the demand was 7. CPU wanted page number 7, but it was not present in main memory. So it's a page fault. That's why it is represented by F. Okay, next page is 0. Whether 0 is there in the main memory before, is it there? It's not there. So it's again a page fault, and we can place that 0 in the frame number 2. Okay. The third is page number 1. Again, page number 1 is not present in main memory here. So it's a page fault, and we can place that page in frame number 1. Okay. Now next. Now your main memory is full. Okay. It is totally filled. Now if you want to bring a page, okay, we have to replace one of this page. Okay, either I have to replace F1 or F2 or F3. Okay, so this is the page 2. First thing what you do is you are going to check whether this 2 is already present in main memory or not. So it is not present here, so it's a fault. Now the next step is I have to replace one of the frame by 2. Now which to replace? What is the name of the algorithm? First in, first out. So which one is the first one? Frame 1 is the first one. Okay. So you have to replace frame 1 by 2. And remaining will be as it is. Okay. Here I have written replace frame 1 first, then 2, and then 2, then 3. Okay. Now next is 0. Whether 0 is already present in main memory. So yes, 0 is already present in main memory. So it's a hit. Okay. So you have to write this as it is 201. Okay. It's a hit. Now next is what? 3. Whether 3 is there in the main memory? No, it's not there. So it's a page fault. Okay. And which frame you have to replace now? Just now we have replaced frame number 1 by 2. So this time you are going to replace page number 2, right? Page number 2. So you will write here 2, 3 and 1. Okay. Now next is 0. Whether 0 is there in main memory, it's not there, so it's a fault. Now which frame you will replace? Just now we have replaced frame number 2. Now we have to replace page number 3. Okay, so this will replace by 0, this will be as it is, this will be as it is. 2, 3, 0. Next page is 4. 4 is not there here, so it's a page fault again. Now which frame you will replace? Just now we have replaced page number, frame number 3. Now we have to replace frame number 1. So you will write 4, 3 and 0. Next page is 2. Now we will replace page number 2. So we will write here 2. Again it's a fault, right? Next page number 3 will replace frame number 3. Okay. Next is what? 0. So frame number 1 now again. So this will be 0, 2 and 3. So it's a fault. Now here see 3. 3 is already present. So it's a hit. So you'll write 0, 2 and 3. It's a hit. Okay. Then 1. Now which one you will replace? 1 you will replace by frame number frame number 2, right? So you will write here 0, 1 and 3. It's a fault, page fault. Then next is 2. So again what you will replace now here? Page number 3. Okay, and the last one is what? It's a hit, right? 0 is already there. So 0, 1, 2 and this is a hit. So it is very easy actually. What you have to remember is you have to replace the frames in order always. First you will replace frame number 1, then 2, then 3, then again 1, 2, 3, 1, 2, 3 and so on. Okay. If there is if the page is already present, then you don't have to do anything. It's a hit. If page is not there, then only you are going to replace the frame by that particular page number. Okay. Now here the total number of references means how many pages are required here. 1, 2. You can count 1, 2, 3, 4 till. See, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So total number of references are 15. Okay. How many page hits are there? 1, 2 and 3. Okay. Total number of page hits are 3. So what will be the hit ratio? 3 upon 15 into 100, that is 20% hit ratio. And what is the fault? How many faults are there? 12. That is page faults are 12. Okay, you can count. And miss ratio will be 12 upon 15 into 100, that is 80%. So this is how you have to solve the problem. This is very important for the exams. Every time they ask this question in the exam. Okay, now we'll see the next algorithm, least recently used, also known as LRU. It replaces the page which is least recently used in the past. That is, we replace the page which is used at the beginning in the past. So here the CPU page number demand, here it is given pages around 20 pages. Okay, 701203, it's a reference string given. The memory size, main memory size having 4 frames, F1, F2, F3, F4. Initially the demand is of 7. It's not present in main memory, so it's a fault. So we will write this as 7 cross cross. Initially only 7 is there in the main memory. Next demand is 0. Again it's a page fault. So we can write 0 in frame 2. Then next is 1. Again it's a page fault. So we'll write 7, 0, 1. Next is 2. Again it's a page fault. So 7, 0, 1, 2. Okay, so now next, now your RAM is full. Okay, your main memory is full. Now henceforth, whatever page number you want to bring in, you have to replace with the any of the frame. Okay, so what we are going to do here? Now 0, whether 0 is already present here. Yes, it is present, so it's a hit. Okay, so you are going to write this as it is 7, 0, 1, 2. Okay, now next page is 3. Whether it's there in main memory, it's not there, so it's a fault. Now which frame we have to replace? This is what we have to see here now. So what I told you, we are going to replace the page which is least recent use. Now 7, you have to compare. Okay, 7. When 7 was used, 7 was used here. Okay, then 0. Okay, then 1 here, and then 2. So which was used long back? 7 was used long back. Okay, so we are going to replace this 7 by this 3. Okay, so we'll write here 3, 0, 1, 2. Okay, now next is 0. Again it's what? It's a hit, right? 0 is already there, so you will write this as hit. Okay, so you write 3, 0, 1, 2. Now next is 4. So which to replace now? You have to check this now again. Okay, where is this 3? 3 is used here. Okay, then 0 here, then 1 is here. Okay, then 2. Okay, so which was used long back? 1 was used long back, so we can replace this 1 by this 4. Okay, so what you'll write here? 3, 0, 4, 2. and it's a page fault, right? Now next is what? 2. So whether 2 is already there? Yes, 2 is already there. So it's a hit. So write 3, 0, 4, 2. It's a hit. Now next is 3. 3 is already there. Yes, 3 is there. So it's again a hit. So write 3, 0, 4, 2. Okay. Next is 0. 0 is already there. 0 is already there. So hit 3, 0, 4, 2. Okay. Next page 3, it is already there, again a hit. So write 3, 0, 4, 2, hits, hit. Next page is 2, it is already there. So again it's a hit. Okay. Now next is 1. Now which to use? So 1 is, where is 3? 3 is used now here, 0 is used here, then 4 is used somewhere back, and 2 is used here. So which was used long back? 4. So we can replace 4 by 1. So we write 3, 0, 1, 2, and it's a page fault. Okay. Next is 2. Whether 2 is already there? Yes, 2 is there. So it's a hit. Okay, so we'll write this 3, 0, 1, 2 as it is. 0 is there. Yes, 0 is already there. So it's a hit. So we'll write 3, 0, 1, 2. Now what about this 1? 1 is already there here. So again it's a hit. So we'll write 3, 0, 1, 2. Now 7. Now we have to replace one of the frames. So where is 7? 3, 3. Which one we have to replace here? Where is 3? 3 is used here. Where is 0? 0 is used here. Where is 1? 1 is used here. And where is 2? It is used here. So which was used long back? 3. Okay, so you can replace this 3 by 7. So you write 7, 0, 1, 2. It's a fault, right? Then whether 0 is already there? Yes, it is there. So it's a hit. So write 7, 0, 1, 2. It's a hit. What about this 1? 1 is already there. So it's a hit again. So write this hit. Now you have to count number of hits. How many hits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 12 hits out of 20, right? These are 20 numbers, pages. So this will be 60% hit ratio, and number of page faults are 8. So 8 upon 20 equal to 40%. So this is a miss ratio. Okay, so this is how we can use this recently used algorithm. And here there are less number of page faults, okay, but more time is required to compare, compared to first in first out. Okay, why? Because we have to search, right? Every time we have to compare, and because of that it consumes time. Okay,